So you saw the new this constructing it from the other side, right? The fencing space. This side, right? Fencing space. So how they put in the concrete together, right? They put the concrete and onto the ground and the cement onto the ground and put water onto the ground. And they are wondering why it's all hard because I felt like going and reading that. The guys were doing it. And they're taking their own full time, right? So maybe next year you will have a canteen. That should have taken them at most 6 months to do. I mean, not even 6 months. Well, for 3 months they should finish it. What I'm saying is 6 months is finishing and all the lights in order to be finished. But at the rate these guys are going, they're digging and there's rain. They're like bailing out water. Maybe the guys are trying on their vast knowledge. Anyway, that's what Kham also do. Then we have ordered this room. By the time Kham next semester would be for most likely. Right? They have ordered a few desks with all the multimedia stuff connected to it and then 2 screens on either side. 3 screens on either side that move stuff from a screen to another. And in the middle there will be a board that can go up and down. Right? At least the board goes up and down, the braids may not go up and down, the board like that for the 2 rooms. There are 2 multimedia inside. And the audio system is going to be different. Right? We have a 6-speaker system in here. Right? You can hear us better. So you realize that it take about 1.2 million from you, right? Yes? 1.4 million? Somewhere around that, but you put to good use, right? They use $1 million to pay me, but it's a separate story. Yeah. I wish, but so they are putting a lot of investment into the system so that the place looks nice, right? So they have ordered this type of thing for the next room of the chair. So the chairs that they have ordered. So things are looking good. Right? And they are starting on May 6th, I think they are starting on the new engineering building. By 2016 middle, they are supposed to finish up to floor number 4. Right? So I kept asking them, you are finishing up to floor number 4 and you are getting the students to go in there. Ritil said, no, you are getting the students to go in there. And then what happens is like a huge brick falls on the and they said, no, they are construction methods to build while people are in there. Right? I again asked them, yeah, people. This is not people. These people even a constructed, best constructed one. I saw some pictures that gave me nightmares. There were some kids, on the ledge outside the wall, on the roof. Was it you? No, right? There are some people who were standing outside the wall, on the ledge of the roof. You see that? All the others are also like you folks are also our students, no? Just imagine some of them, the guy. So you never know, that kind of thing can happen. Right? Seriously, something like that can happen. So I don't know. But they said it's fine. So you're going to get the first 4 of the floors by middle of 2016.
and by 2000 and then 2015, by about August, September, SLIT is starting architecture. Right? Architecture is the first step towards going into other markets like quantity surveying and so on. So SLIT will have architecture by 2015 February, and by 2016 end they are going to have nursing, right? So that is the first step towards having medicine, I think, in the future, right? So one day when you guys walk out of this, it will be a massive place. Folks, you can't do medicine and nursing with mathematics, right? So you are here to stay. Okay. Now you have not. I have seen the master plan for the next 15 years, and it's really great. It's looking really great, right? So for the next 15 years, there's a master plan for SLIT. And I just told you the first two years of it. So there's more to come in the future. Right? Okay. So here's the first question that we are going to answer from the three-phase area. By the way, you folks saw the building, right? I showed you, right? Okay? That is ZL, and ZL, A, B, and C. Quiet. So this is a load, right? All of them are simple letters. So ZL is 3 plus J4, and I give you EAB to be equal to 173.2 with an angle of 0. I haven't put the volts, obviously it's volts. E of BC is 173.2 with an angle of minus 120, and ECA is 173.2 with an angle of 120. So they give you the generator voltages, right? So this is A, that is C, this is B. They give you the generator line voltages, right? Remember, this is not A of N, this is AB. So they give you the line voltages, and the first question that they ask you is, what is V of AB? Can somebody tell me what is V of AB? Which means line voltage at the load side. What would be the line voltage at the load side? Can somebody answer that question? Huh? Yes, what is it? Yeah, same as the AB. Yeah? Not rocket science. So it is the same as EAB, because why? I just showed you how both of them are connected. See, VAB is equal to EAB. So there you are. And that is equal to 173.2 with an angle of 0. This is a question from the book, right? B is VA of N. how do you calculate the phase voltage at the load? How do you calculate phase voltage at the load? Yes, what is it? How do you calculate the phase voltage at the load? What is it? Now you are going to look at whether you have any expression that interconnects phase voltage with line voltage. Right? So what is the equation that connects the phase voltage to the line voltage? What is it? You have closed the book. That close to leaving one. Okay, that's correct. Take 1%. So here's the expression that you have. Right? The expression that you have is, you have VL, right? VL is equal to root 3 times V phi angle of that phase plus 30. Right? That's what. So if you draw basically the phasor diagram, if this is V phi, right, you will have this to be root 3 into V phi, that is VL, right? Magnitude has been increased. Then that is going to be equal to 30. So I don't know, whatever the phase here, you add to that another 30 degrees. So if I do that, VAN, we already have VAB, which is 173.2 with an angle of 0, right? With an angle of 0. So what is VAN? So we know, right, that. Right, we know that, but we are supposed to find out what is this. So immediately you know this is 173.2 root 3, because why? This is VL. What we are trying to find is V of phi, which should be root 3 factor down, and the angle of this is what? 0. So the angle of the other one would be what? Minus 30 degrees. There you are. That works out to be 100 volts with an angle of minus 30 degrees. Right? Angle of minus 30 degrees. Okay, fine. There you are. Now, part C is, what is I of AN? How do I find I of AN? Yes. So I am asking you to find the phase current at the load. What would it be? Right? Yes, but how do you find IA? Now this is AC theory, directly AC theory. Yes, how do you find it? Yeah, absolutely. Now, though your diagram looks different, the ideas behind it is still the same, right? Now you realize you have that voltage, right? you have this voltage, right? And this is known. So you have to find IAN. What is it? V equals IR, right? So you would have V, which is 100 volts. So I'll drop the volts because we know it's volts. Minus 30 degrees is equal to I of AN into R. R is 3 plus J4. Right? 3 plus J4. And then also 3 plus J4 is equal to 5 with an angle of 53. Right? 5 with an angle of 53. So immediately you know IAN is equal to 100 over minus 30 over that value, which will be 20 with an angle of minus 83, right? So it is actually 20 amperes with minus 83 angle D. So you realize all the AC theory stuff, everything that you did in the AC theory comes back here. D is what is the average signal, right, power of one phase, right? What is the average signal power of one phase? How do I do that? What is the average signal power of one phase? You understand, if I know I and B, then I can use IB, and this is the average power that I am asking for. It is cosine of the angle difference between those two. Right? Yes? So, immediately I know that VAN is equal to 100 with an angle of minus 30, and IAN is equal to 20 with an angle of minus 83. Right? Minus 83. So immediately I can now find P phi, which is average power of a single phase, is VRMS, right, into IRMS, and cosine of the angle difference between these two, which is 53, right? Cosine 53, and that is equal to what? Where is it? Here. It's 1203 watt, right? 1203 watt. Or because it is the average signal power you are looking at, you realize the Z is made out of R and an inductor, right? XL, and this is IAN. So you could also have, right, written it as 20 squared into R, right? 20 squared into R, which turns out to be something like 3 plus 3. Right? So how much is that? This is 400, 1200 watts. See? Of course, here we have taken other things. So these are base approximations. Right? I have taken, otherwise if you don't approximate it, you would have got the same answer. Right? You would have the same answer. Is that okay? Right? I mean, okay. What would you get here? E. Total, right? Average signal power at load. So this is for a single phase, right? This is for a single phase. So if you want to find the total, how much would that be? 3 times the P phi, each phase will be giving out the same amount of dissipating the same amount of signal power. So it is 3 times 1200, right? 3.6 kilowatts, right? 3.6 kilowatts. Then also we know that P total is what? Root 3 VL and IL cosine the angle between V and I, right? Also this is also an equation. This is also an equation we used, right? Now how much is this? Root 3 times VL. Yes, how much is VL? VL is VAB, right? VAB was how much? 173.2, and IL is the same as I phi, because why? This is a star connected network, right? So that is going to be 20, and the angle difference between that and this is going to be what? Cosine of 53, right? And that also works out to be 3.6 kilowatt. You can choose which equation you are going to use based on the information you have. If they give you the line voltage, use that equation. If it is the phase voltage, use the earlier one. Right? If you know R and X, use I squared R. Perfect. Right? No problem at all. Then the next question is F. Right? Determine the reactive power for each phase and the total reactive power, right? Find the reactive signal power for each of the phases, and so also straightforward, no? So each of the phases will be what? VI, and you got sine of the angle between V and I, right? So you know that V is going to be equal to 100 with an angle of minus 30, and I was 20 with an angle of minus 83. This is known. So capital Q of phi. Now this is AC theory, no? Right? This is after you take this basically the right line voltage, and you find out the phase value of the voltage. Everything else is what? Simply AC theory. So this is V 100 times 20, and you have sine of 53, right? And that's going to be equal to what? This I have calculated is approximately equal to 1.6 kVAR, right? Remember VAR, right? And then I can find the total is 3 times Q phi, because each phase will dissipate the same amount. So this is 3 times 1.6, which works out to be 4.8 kVAR, right? If you right did not like this, you could have also calculated this using I squared into I squared into XL. This is I squared into XL, which is 20 squared into 4, right? 20 squared into 4. And then how much is this? It's 1.6, right? Right? So it's the same answer. Then you could have found the QT by like multiply this by 3. Or, so this is one, this is the next method. Or you could have also written it what? Capital QT is equal to root 3 times VLIL, right? And sine of the angle between V and I, which is what? Root 3 times VL is 173.2, and IL and I phi are the same for a star network, 20, and sine of 53 degrees, which would have turned out to be 4.8 kilowatt. So you know now three different methods of finding this. You should get the same answer, right? 3 different. This is nothing new. This is directly from your AC sort of theory. Now, G. What is the power factor of the load? Right? How do I do this? What is going to be the power factor of the load? Now you ask yourself the question: what is the definition of the power factor? It is what? The angle between. It is going to be the cosine of the angle between V and I. Right? So tell me the angle between V and I. 53. 53 no? Cosine of 53. Right? No, that's only half the answer. Is it leading or is it lagging? Because why? We already said once you give a certain value for the power factor, you also have to give whether it is going to be leading or lagging. Is this leading or lagging? How do you know? Yes, how do you figure it out? Yes, could someone tell me whether it is leading or lagging? Lagging. Right? How do you say it's lagging? It is inductive. It's inductive. Inductive ones are always lagging because it is 3 plus J4. If it was 3 minus J4, then it is what? Leading, because why? That would be a capacitive circuit. So this is going to be, you have V and I here, this is V and I. You realize the angle between V and I is 53. So this is cosine of 53. That works out to be how much is that? 0.6. And it is lagging. What? Because it's inductive. Right? Because it is inductive. Or if you are unhappy with that, there's always a way of checking it. How? You know that V is equal to 100 with an angle of minus 30 degrees and I was 20 with an angle of minus 83. Draw the phasor diagram. This is the reference. This is minus 30 degrees. This is minus 83 degrees. Who is leading whom? V is leading I, and then you know, according to our thing, basically civil, according to that, this is a lagging power factor. Right? Is that okay? Then let me ask another little question. You had a load of ZL, which was 3 plus J4. Right? What is the angle of ZL? Yes, what is the angle of ZL? Huh?
Yes, what is it? Tan inverse 4 over 3. How much is it? 53. Right? 53. So, this angle is in fact this inverse tan of 4 over 3, and that turns out to be 53. What is cosine 53? The 0.6. What is this? The power factor. So if somebody asks you to find that value of the power factor, what would you do? You forget everything. Find the angle of the load, because the load is the one that is going to drive an angle between the V and I. Right? Just think to yourself, if you take this same problem with ZL is equal to 3 with no inductive power, what would be the power factor? Yes? Could you tell me? Yes, what is it? I take the load, I take out the inductive part, and I only keep 3. What would be the power factor of the circuit? Yes? 1. Go back and do the calculation again. Here, you have V phi to be equal to 100 with an angle of minus 30. And I of AN is V of phi over ZL. Right? This is 100 with minus 30 degrees over, now this is ZL is just 3. Right? There's no angle. And that turns out to what? Something like 33 with an angle of minus 30 degrees. Now, what is the angle, right, between I and V? 0, because this is minus 30, that is minus 30. So if it was completely resisting, the power factor will be 1, because that cosine of 0. So this is one important fact. If your system generates some power factor that is totally due to that reactive component of your system, if I even put a little bit of the reactive part, there would be a value of cosine angle between them. Right? This is the reason why in industries they try as much as possible to eliminate the reactive part. How do they do that? This is how they do that. They have the resistance, they have the inductance, onto that they put a capacitance. This is 3, this is J4. They try to make this value minus J4, so that when you take a look at it, this inside the ZT becomes 3 plus J4, right, minus J4, which is in fact 3. This is what they do in the industries by putting a capacitor there, so that they can make that particular power factor equals 1. Right? That's what they do. Right? And they do this automatically. They have this little thingy. When the thing changes, the angle changes, it also changes the value of C, so that reactance matches with the reactance of the inductance which is generated by motors. Right? Motors have just inductive values. It has some sort of winding that will generate inductance. You put a capacitor there and eliminate. Right? So, ladies and gentlemen, that is the type of questioning that you will see in the book, right? When it comes to this type of circuit. Of course, there are more complicated ones where they have this line impedances and so on, which I did, I guess, last time, but I am not going to do it this time because there are lots of other things to be done. So if you know all these things, you are fine, right? But of course, there will be a twist when it comes to the examination because you can't ask the same questions again, right? So it's good if you can do the problems that I have indicated to you in the right? Okay. With this, 3 phases finished. Right? Next time what we are going to do is we are going to start on the transformers. Though I have time, I am not starting transform because you need to do magnetic circuits, then only I can do the transformers. And on that particular area, transform area, can you remember I said if you have a speaker, if you connect some other speakers to it, your signal actually drops. Remember I said that? If you connect a speaker, remember I said you have impedances of speakers, you got basically phone that has to be matched with, otherwise your signal. I am only going to concentrate on showing you how that really happens with whatever you did in the transformer knowledge. Right? So that's what I am going to do when I come back in a couple of days. So the lecture today is over. If you have any questions, I can answer them. Right? You okay? Yeah. The angle between P and P is this I go. That's a good question. Excellent question from them. Where is it? Which one? Was it G? E. Oh, nobody saw this except that gentleman. This is wrong. This is VL, IL and cosine between that. Right? VL is what? VL is 173.2 with an angle of what? 0. Right? And IL is what? 20 with an angle of minus 83, right? Is that correct? So this is wrong. VL, IL, angle between those two would have been 83. Right? I like it when people pay attention. Right? That's very good. Anything else? Anything else I can answer? I think my answer originally was right. See, I do it by after doing this practice for long enough time, I don't even think about it now when I answer. This is right because why? Because if you go back and look at that equation I did, see, I took this equation. See, I took that equation, and onto these two I have substituted this, and basically this angle was what? The angle difference between the phase voltages and the phase currents.
Very good. Because of this gentleman, it got highlighted. Right? Now here you realize in this equation, E of this phi, this is actually the angle between the phase voltage and the phase current. And then after that I have substituted for these two. So actually what you have here is basically okay. So this is wrong. This is wrong. This is correct, because this should have been the angle between the phases. Right? Angle between the phases. Because we have been working on this question for long enough period of time. That some of these things we do without thinking, automatically. But you are doing it for the first time. So if you ask the question, I will be able to go back and explain it. Right? Otherwise, if you didn't ask the question, you would have been like wondering about it all the time. Anything else I can answer?